video to explain the hydrocarbons, and for the sake of my students, I saw some of your questions, and I decided to do this video just to explain some things because you must not fail any question from hydrocarbons in your JAMB. I will not be happy with you sincerely. I know I did one video on it, so I'm doing this to make sure that I explain everything clearly. So um it's very important that you understand these things because they are very, very important. So I will not waste time defining hydrocarbons. We all know what they are. You know their classifications. They are alkanes with A, alkenes with E, alkynes. So their classification is based on the type of bond that exists between carbon to carbon. So, and these compounds are found in natural gas, petroleum, and they are used majorly as fuels and raw materials for industry. Hydrocarbons are used basically for fuel and as raw materials for industry. If you watch the previous video that I did on organic compounds, I talked about this. In fact, we've answered a question on that. The reason why I'm even doing a video is about this matter, this question. A question that talks about, I think it's JAMB, was it 2010 also, that talks about one of the major uses of hydrocarbons, one of the major domestic use of hydrocarbons, yes. And there is plastic there, there is fuels there, there is even hydrogenation and several other uses. And fuels is the answer. So I've explained it, I know, in the group. So I don't want to waste time, I beg, let's go. So please, these are basic things. Now, structure is very important. Alkanes are carbon to carbon single bond. Alkenes are carbon to carbon double bond, while alkynes have carbon to carbon triple bond. The nature of bond that this compound, these varieties of compound have, or these classes of hydrocarbons have, affect their reactivity and even physical properties. This is very important. It's a fact and you must know it because you'll be tested on that. I have seen syllabus, so you can also check it. Know their general formula. I don't know how you do it. Oh, please, if you need to bring your book closer, bring your book closer. Yes, and copy this formula. The formula for alkanes, try and master it by all means. Know the formula for alkanes, the general formula for alkenes, and the general formula for alkynes. Know this. If you don't know it, please cram it. Pick just one day and cram it and know that if they wake you up from sleep, you can tell it. This question has appeared on several occasions in JAMB past questions. I have seen it again and again. Please, I beg you. For alkanes is there CN H2N plus N plus 2. CN H2N plus 2. What does this N stand for? This N is a number. It can be any number. For example, if N is 2, if carbon is 2, that's C2, then hydrogens will be 2 times 2. That's if carbon is 2. If N on carbon is 2, the N close to the 2 for hydrogen will also be 2. So N is 2. H will be what? 2 times 2. That's for the N plus 2. That's 6. So this is how you will know their members. You use that general formula to generate their members, the members of their group. If this is not clear, don't shy away. Don't assume as if you know. Drop a comment section. That I like what Believe did. She came to my WhatsApp and chatted me that it was not clear for her, and I explained it. So if anything is not clear, please drop it. The same thing, the formula for alkanes, for alkynes. So those are just general formulas for generating their member. Now we have answered several questions so that you would know that JAMB asks questions in these areas, like you cannot avoid them. JAMB will test your knowledge on this, and they have mentioned it in the syllabus. So you have to know their boiling point. They will test you. They will bring 5 organic compounds or 4. and say which of these will have high boiling point. Can you imagine? Very simple, but if you don't know, you don't know. For example, a hydrocarbon that has 2 carbons and another one that have 5 carbons, which one will have low boiling point? The one with 2. If I'm small, I can jump easily. I can move around easily. Wind can carry me easily. But someone that is heavier with plenty carbons, common sense should let us even understand some things, even though there are some facts. But we are talking about hydrocarbons. When we are talking about hydrocarbons, this is exclusively true. That is why petrol is lighter than diesel. Petrol is having like, I think 6 carbon, 5 or 6 carbon, while diesel is having about 8, no, kerosene 8, maybe diesel is around 10 carbons, 10 carbon chains. Can you see it? So diesel, if you want to boil diesel and petrol, which one will boil faster? Petrol, of course, because it have a fewer number of carbons. So know that about boiling point. The molecular weight is what determines the boiling point. The bigger the compound, the slower it will boil. It will not boil faster. It will need a long time, a long temperature, a higher temperature to boil. Please, I beg you know this. So melting increases with molecular weight and symmetry. Yes, when we talk, some hydrocarbons also exist as solids. Yes, some exist as solids. So how does, in fact, the more heavier, the more bigger a hydrocarbon is, the more likely it is to become solid. We are going to talk about saturation also. So if we are talking about melting point, how fast it melts. So the molecular weight, if the higher the molecular weight, or the molecular weight will also affect melting. So if the molecular weight is higher, the melting will also be higher. The melting point, the amount of temperature needed to melt it will also be higher. Please, these are just simple things. Solubility in water. Inorganic, they are insoluble in water. Hydrocarbons are insoluble in water. Have you ever seen palm oil dissolve in water? No. Try pouring it, it will be floating. It's also an organic compound, even though it may not, it's not completely a hydrocarbon because they are fatty acids. So let's go. So alkenes and alkynes are generally more reactive than alkanes. This is true, and you have to know it. Oh, this is a question. All these things that you see me put here on this PowerPoint, I know what I'm doing. I'm picking questions directly to explain. Alkenes, they have double bond. Do you remember? Alkynes, they have triple bond. They are more reactive because normally, under normal ground, carbon should have 4 bonds. If it have 4 bonds, it will be stable. And it must have the 4 bonds. But then carbon will prefer to have carbon to carbon single bond. If it has carbon to carbon single bond, it will be highly stable. But if peradventure it has carbon to carbon double bond, it will not be stable. Hence it will be reactive. Carbon to carbon triple bond, wahala deo. It's not satisfied, it's not stable, it cannot be stable. So it is likely to react faster. Do you know why group 7 elements are highly reactive? Group 7 elements, do you remember group 7 elements? Fluorine, chlorine, bromine, iodine, astatine. Do you remember them? They are the most reactive elements on Earth. Why? They need only 1 electron to fill their outermost shell. Do you remember electronic configuration? So the first element, the first member, that's fluorine, is the most reactive element on Earth known. Hey, in case you see a question like this in JAMB, which of the following is most reactive? Or what is the most reactive element on Earth? That one a bonus. So I hope you get it. Never forget that alkenes and alkynes are more reactive than alkanes. Alkanes are stable because they have carbon to carbon single bond. I remember we've answered a question on catenation. They say the ability of carbon to form bond with itself again and again is referred to as catenation. And it's JAMB question, past question. God will help you guys. So chemical properties and reaction. I've already talked about reaction a little. So Alkanes undergo combustion. What do we mean by combustion? Burning. You have gas cylinders at home, you burn it. You know what you are burning? You are burning ethane, propane. These are basically the ones that they use in our gas cylinders. So they undergo combustion. I hope you know burning is a chemical process and not a physical process. Hey, do you remember? Because there is a transformation that is irreversible. That's what we call chemical process. So never forget to. I'm bringing a lot of things. Let me be fast. I want to finish this. Alkanes undergo addition reaction. Yes, when you are not satisfied, you would eat. So that's what exactly is happening. I have double bond and a single bond I want to make. So if I find somebody that will donate something that I can make a bond with, I will break this double bond and add. I will collect that person and add. So that's addition reaction. Such as hydrogenation. When it gets hydrogen, it adds it. That's hydrogenation. Halogenation, it also undergo halogenation. Halogenation is adding of a halogen. I just call the halogens not quite long. So they can form halogens. We know haloalkanes, they are very important, like trichloromethane. I once mentioned that it is used as anesthetic, not anesthetic, anesthesia. Yes, when they want to do surgery, they inject with anesthesia so the person will go dump or numb and will not know what's happening. So some of these are haloalkanes. They are very important. Some are used as detergent, cleansing agents. So I hope you get that. So alkynes, they undergo addition reaction to triple bond. They are not satisfied. Highly more unstable than alkenes self. Okay? I hope you get this. So, so I've even stated it here that in the second to the last point that alkynes are more reactive than alkanes. So all can combust to produce carbon dioxide and water. All of them, they can burn to produce carbon dioxide and water. Uses and applications. I have seen this again and again. Master this. Know their uses in industry. Know their uses domestic. Know their uses in medicine or in pharmacy. Know their uses. They will ask you, is sure. Alkanes are used as fuels and lubricants. Alkenes, that's not only that, but basically, majorly. Alkenes for production of plastics. Yes, polyethylene bags. All these things that we call nylon. Do you know that they are product of alkenes? Yes. So they undergo reactions to produce all those things. Then we have alkynes used in welding. Acetylene. Yes, I answered a question similar to this in the last video where we are talking about the fuel that miners use in their lamp in the olden days, miners' lamp. They use acetylene. Acetylene is the same thing as ethine. You would see it also. They also use it in welding because it helps to produce high amount of temperature. Not electric welding, or abeg. The local welding, they use cylinder to do. Please know this. Yes. Okay, I've mentioned all this except one, so I'll mention one. That's saturation. If you want this PowerPoint, please just drop in a comment section. I will share it with you. Okay. Saturated, unsaturated, and unsaturated. Yes, they will ask you a question here again. And we've answered the question also in the last video. You see how JAMB asks their questions anyhow. When we just say saturated, satisfied, I don't need anything. And it's only alkenes that are saturated. Alkenes have double bond, so they are not satisfied. Alkynes have triple bond, so they are not satisfied. So they are unsaturated. And they react. They are the ones, these two, alkenes and alkynes, they turn bromine water into colorless. They react with bromine water to change its color. I remember we asked a question and see the way Jan put the question. Two elements, two substances, X and Y. Y decolorizes bromine water while X does not decolorize bromine water. X likely belongs to, say alkynes, alkenes, alkanes, and whatsoever. Can you see the way, the trick? Too, they are trying to assess. Do you even know the difference between saturated and unsaturated? Very, very important, please. Summary, I'm rounding up. Hydrocarbons are vital. Alkenes, alkynes, they differ by bonding and reactivity. Properties determine their industrial and daily applications. So their properties will determine where they will be used. Thank you very much. So if you are not my student and want to join us, please comment on the session. I want to join your JAMB tutorial group. I will do that. I would add you. Thank you very much for watching. If you have not subscribed, you can subscribe. I drop valuable content, important things. If you have question, I create video on it so that not only you, others also will help. I share tips. In fact, there is one video I just make, how to predict JAMB questions using JAMB syllabus. Never go to JAMB exam without listening or watching that video. I'll drop the link in the comment section. Go and watch that video now. It will be very helpful to you. Thank you and bye.